Okay, any other ones then? This is the angles of a circle homework. Oh, good. Okay, ready? Number 12? Number 12. A diameter AB and chord CD. Okay, let's stop right there. So we have the center of our circle. The diameter is AB. AB. And chord CD intersect inside circle O at X. So we're going to draw a chord that's not the diameter. And that is CD. And they intersect at X. So first you have to draw a picture correctly, right? Okay. Arc AD is 128. Angle AXD is 74. Find all of those arcs, draw a diagram. Okay, the arc that would be the easiest to find first would be arc CB. We're going to find this arc first because we know that angle that I just drew, the two angles, the 74, that angle came from adding the arcs and dividing by 2. The 74 came from adding the arcs, 128, I'll call this CB. So how do you find an angle inside your circle? You add the arcs and divide by 2, whereas to find one outside, you subtract the arcs and divide by 2. So we know how to work backwards here. We know we can take that 74, we can double it, and then we could subtract 128. And now we know that that is not drawn to scale because arc CB, the measure of arc CB, is 20. So, picture not drawn to scale. So now we know that arc. We know this angle too. They're vertical angles. Okay, cool. The rest of the way to find the rest of the arcs, we're going to use the diameter to our advantage. Every time you have a diameter, you're excited because that helps you out a lot. If this is the diameter, then this cuts our circle into 2 semicircles, 180, 180. So to find that first one, we know we subtract 20 from 180, and then we subtract 128 from 180. And we now know all of the arcs of our circle. CB is 20, AC is 160, and BD is 52. Good? All right, please look at number 20 with me. These are all very good problems. First of all, on number 20, we have a few things going on. We have inscribed angles. We have like 4 inscribed angles. We also have a quadrilateral inscribed in a circle. And we learned that if a quadrilateral is inscribed in a circle, opposite angles are not congruent, they're supplementary. Because those opposite angles end up intercepting the whole circle. The whole circle is 360, and to get an inscribed angle, you divide by 2. So that's y. So I can find angle x right away. We do 180 minus 76, and that's going to be angle x, 104. All right, now we need to find y and z. Once we know y, we will know z. Because angle z, you take his arc and you divide by 2. So z is going to be half of y once we find y. What are your ideas to find y? There's tick marks on that quadrilateral. Do you see that? Those tick marks are there for a reason. Probably should use them in some way. Instead of looking at that quadrilateral as a kite, which is probably what you're tempted to do, let's use our circle theorems. We know congruent chords intercept congruent arcs. Congruent chords intercept congruent arcs. So, if this chord is congruent to this chord, then by golly, this arc is congruent to this arc. So I'm going to call this one y, because they are both y, because our chords theorems tell us they are. Now I'm going to take that 104, and I'm going to double it. I hope that's okay. I'm going to take this 104, and I'm going to double it to get 208. I know that this whole arc is 208. And these pictures get messy quickly. But do you see how angle X is opening up to that major arc? That major arc is 208. So wait a minute. Now all I have to do is divide it by 2, and I'm back at 104. So Y is 104, and Z is 104 divided by 2. Z is 52. Did that logic make sense? Inscribed angles are half their arc. So if you know the angle, all you have to do is double it and you get that angle's arc. Next is 21. Whoa, what's going on here on 21? Okay, we have lots of tick marks here. Let's work with the only number we're given. Let's work with the 80 there, okay? So I'm going to take this 80. I'm going to divide it by 2, and I get 40. Now, where do I put that 40? I follow the lines. It's whatever angle's opening up to 80. Follow the end points of the arc. Okay, so that angle right there is 40. What can we do from there? There you go. Congruent chords intercept congruent arcs. Take that H off of that ARC. Okay, there we go. I like that. So that's 80. There we go. 80, 80, 80. Okay, congruent chords intercept congruent arcs. That's what Miss Tanton was missing. Okay, so this is going to be easy from here. Y is 40 now that we know that his arc was 80. And then what about angle Z? We're going to do 360 minus our 80s. And we get that this arc is 120. And then angle Z, even though it's not called an inscribed angle, its vertex is on the circle. So when your vertex is on the circle, that angle is half of its intercepted arc. So Z would be 60. Thanks, guys. Subtract from 360 is how we got that 120. So no, those triangles were not congruent, but the congruent chords intercept congruent arcs was the key to that problem. Okay, last one, 22. Ooh, this one's fun. Once again, be careful. When a radius meets a tangent line, you get a right angle. We don't have any radii. We don't have any radiuses. So don't start adding right angles every time you see a tangent, okay? Just be careful about that. If that arc is 100, let's just start doing this. Then that one is 50. We have alternate interior angles. Alternate interior angles. Parallel lines cut by a transversal. Remember those theorems? So now we know that Y is 100 because an inscribed angle is half of its intercepted arc. And now we know all of the arcs except for this one. So we can take 100 plus 100 plus 90, and we can subtract that from 360. So 360 minus 290. This arc is 70, and so Z is 35 degrees. Good?